Hello and welcome to this lecture on analytic function. We see some important properties of analytic function in this video. So the first property will be if f of z is analytic, then we have to show that the curve, the function u of x comma y is constant and v of x comma y is constant and both are orthogonal. So in school days we have studied that. What do you mean by orthogonal? A product of two slopes is equal to minus 1. If I consider m1 as a first slope and m2 as second slope, now we have to prove that the product of two slopes is equal to 1 minus 1. Now we say that m1 related function, let me consider f of x and here it be g of x. These two functions are orthogonal. So we use the same thing to prove this theorem or property. So let me take that f of z equal to u plus iv, where u and v are the functions of x comma y, and it is analytic. Analytic means it will satisfy the CR equations. So ux will be equal to vy and uy will be equal to minus vx. Then as per the given property, I may take that both functions as constant as equation 1 and as equation 2. Okay. On the next, here we have to be very careful. So simply what I'm doing is, if I differentiate this first equation with respect to x, okay, with respect to x means simply what you will get, du equal to 0. With respect to any of the variable, the constant will be 0, no? And here dv will be equal to 0. So let me take equation 3, 4, and by using the total derivative, du can be written as dou u by dou x dx plus dou u by dou y dy. If it is having third variable, now we will add dou u by dou z dz. So therefore, just consider this as equation 5. If you see the equation 3 and 5, du, the left hand side is equal, now then right hand side should be equal. So therefore, we equated to 0. In a similar manner, we used to, if I differentiate this, we will get dv equal to 0. And by using total derivative, dv can be written as dou v by dou x dx plus dou v by dou y dy. And if I use this two equations, both the LHS part are dv. If it is LHS are equal, na, then RHS has to be equal. So if RHS is equal, na, we will get this total relation with equal to 0. Next, from this equation, just take this. Okay, let me take this. We used to write the same equation as dou u by dou x can be written as ux. Here it will be uy. So ux dx plus uy dy equal to 0. So what's our ultimate aim? We want to find the slope from each of the function u and v. So here dy will be equal to ux plus dx, and dy by dx can be written as minus ux by uy. So I'm getting that. I'm naming this as m1. And from this equation, I may take that vx dx plus vy dy equal to 0. And from this, if I find the dy by dy value means already dx dy, and if I multiply with that v uh, vy will be there, and if I bring dx, dy by dx equal to minus vx by vy. So this is what I'm naming this as m2. Here it is m1. So finally, if I multiply the product, to prove that if I'm multiplying both m1 and m2, what will happen? Minus ux uy into minus vx vy. I already know that the function f of z is analytic. So the both function u and v will satisfy the CR equations. So what will be the CR equation? Ux will be equal to Vy and V Uy will be equal to minus Vx. So we may write Vy. I may write Vy as Ux. So I may cancel Ux. Here it is minus, here it is minus. I may cancel both. And also Uy can be written as minus Vx. So I may cancel both. So here I am getting minus value. I am cancelling out the both. Okay. So if I am cancelling out or last, finally I will get minus 1. So I have multiplied the slopes of two curves and I am getting that minus 1 na? So it is orthogonal. Both curves are orthogonal. So finally we get, by using the CR equation, we prove that a product of the slopes will be equal to minus 1. Therefore the level curves are orthogonal. And next we see one more property. Simply, if f of z is analytic, then modulus of f of z is constant. Then we have to prove that f of z is a constant. So these are the assumptions. Okay. With this assumption, we want to prove whether f of z is getting a constant value. And similarly, we know that f of z will be equal to u plus iv and modulus of f of z will be square root of u square plus v square. Already in the given data, this modulus of f of z will be equal to a constant. So it is equal to constant and we know this equation, both the equation having f of z as a, on the LHS partner, then RHS part will be equal to are equal. So modulus of u square plus v square equal to c. Then if I take the square root to that side now, I will get this equation u square plus v square equal to c square. And then I am differentiating the first equation with respect to x. Just see, this is our first equation. U square plus v square. U square plus v square equal to c square. If I am differentiating this, how I will get it? Ux plus 2v vx equal to 0. I am getting the same answer. So if I am taking 2 from this both elements and I am bringing that to right side, then it will be 0 by 2. So finally I will get a 0. And if I differentiate the same first equation with respect to y, means I will get the value of 2u uy plus 2v vy as equal to 0. And finally I am getting this equation. Then from the equation 2, 3, see, already we know that f of z analytic. F of z analytic, ux will be equal to vy and uy will be equal to minus vx. Okay. So with this, just substitute the into 2 and 3. So I'm just taking out the second equation. I won't change that anything. I'm just take the second equation and then I may take the third equation and I make some other changes. What is our third equation? Ux, third equation uy plus vvy equal to 0. So the CR equation ux can be written as vy, uy can be written as minus vx. So here I am changing out that vy can be written as minus vx and vy is there. And also we know that vy will be equal to ux. So here I am that changing that it will be equal to ux. So finally, I am getting as new equation number 4. So what I'm going to do is just take this is equation 2, multiply the second equation with u. So I am getting that u square x ux plus v u into u vx. This will be the equation. And here on the right hand side, see, I am just what I'm doing is multiplying u with the second equation and 2 with the fourth equation. I'm just multiplying v on the fourth equation. And here, see, if I take this term to the side, we can write that u square vx ux plus v square vx. So in this approach, we may consider that ux u square plus v square equal to ux plus vx. Okay, and these both the terms are similar, so each one will get the negative value. Okay, so finally u square plus v square can't be a 0, and we must have that ux vy ux equal to vy should be there. So here ux plus ux equal to vy vx, and u, therefore ux can be written as vy and ux can be written as vy, and it is equal to, with this equation, equal to 0. So definitely modulus of f dash of z will be ux plus ivx. So I am taking that ux equal to 0 and vx is equal to 0. Therefore, f dash of z should be 0. When if I am differentiating any of function it comes with 0, na, then f of z should be equal to a constant. Okay. So therefore, f of z is constant. That's